And let's go. So, welcome everybody to today's session of Multicloud Happenings. My name is Nathan Fuzzi. I'm joined by my co-host and good friend Vishal Patil. Vishal and I are product managers here at Oracle, focusing on the Exadata database service and base database service, both in Oracle Cloud and in Multicloud. And we're extremely excited today to be joined by Robert Greene, Vice President of Product Management for Oracle Autonomous AI Database. Robert, thank you so much for being here.
Yeah, happy to be here today, Nathan.
Thanks. So for today's session, I'm going to quickly cover what Oracle Multicloud is and talk about its unique benefits. And then Vishal is going to share the most recent Oracle Multicloud service updates and region launches. And then we're going to hand the reins over to Robert for a deep dive into autonomous AI database, including a console walkthrough. Please use the Q&A function at any time to ask questions, and we'll answer them as we go and cover any remaining questions at the end of the presentation. Our discussion today and any future plans or dates we discuss are not a commitment, may not be incorporated in any contract. As always, if you have specific regional availability, service, or feature requests, please reach out to your Oracle account team or us directly, and we'll be glad to work with you. We like to say that Oracle Multicloud gives customers the best of both worlds, but how is that? Well, Oracle has built partnerships with Microsoft Azure, Google Cloud, and AWS to run Oracle Cloud infrastructure inside their data centers and to make Oracle database services available to their customers through their marketplaces. That physical co-location of resources really the key to the offering because it allows us to deliver ultra low latency between that partner hyperscalers application services and Oracle database services. And another key aspect of Oracle Multicloud is the integration of Oracle infrastructure and services into the partner hyperscalers portal, APIs, and even native service integrations that enable management and monitoring from within the partner hyperscalers ecosystem. Now, all of this means that you have access to Oracle database services in the same cloud environment where you're developing your applications and where you want to leverage your business data that resides in Oracle database for things like AI and analytics. Now, the services available include the Autonomous AI Database that Robert will talk about, which is a cloud native and fully managed database running on top of the Exadata platform. There's also the Exadata database service, which gives you the performance and scale of Exadata with cloud automation for database lifecycle management while still giving you full administrative control. The base database service offers a lower cost database for non-mission critical applications, and the autonomous recovery service provides a fully managed backup solution that includes backup security and immutability. And finally, OCI Golden Gate gives you a fully managed solution for high performance data integration and replication. So what makes Oracle Multicloud unique? Well, there's the fact that Oracle AI Database is a converged database, meaning that it supports all modern data types and workloads. So you can deploy the same database to support every use case. And that simplifies your architectures and your deployments, and it means you can reuse your administrative skills everywhere. And then there's the extreme performance of Oracle Exadata, which is able to run the largest and most demanding database workloads in the world. And it enables you to run Oracle RAC in the cloud, which provides extreme availability and scalability. Our cloud services come with advanced security capabilities like strong always on encryption and ransomware resilience. And autonomous AI database is only available in the cloud. And with that, I'll turn it over to Vishal to cover service and region updates. Vishal?
All right, thank you, Nathan. Okay, so we have this portfolio which is comprehensive for AI database, Oracle AI database. We have services which are fully managed, such as autonomous database. We have serverless and dedicated deployment option for that. We have co-managed services such as Exadata database service. We have dedicated and exascale infrastructure deployment option for Exadata database service. And we also have base database service. And there are other services which Nathan mentioned, such as Oracle Golden Gate, which is a fully managed service. Then we have Zero Data Loss Autonomous Recovery Service. We have Oracle Data Safe. Now, all of these services are natively available in our cloud services partners, these hyperscalers like Azure, Google Cloud, and AWS. As you can see, these services are broadly available in Azure, Azure being the first partner in the multi-cloud. And then Google Cloud is catching up with, as you can see, we have Oracle Golden Gate planned for Google Cloud, which is coming next month. And we will have another session in one of the multi-cloud happenings future sessions specifically for Oracle Golden Gate in Google Cloud or in multi-cloud for that matter. Next slide. Not just the capabilities for Oracle AI Database and the services, but we are also striving to make these available across the globe. As you can see, Azure already has 33 live regions for Oracle AI Database at Azure. We have 15 live regions for Google Cloud and 2 more are planned. For AI Database at AWS, we are at 18 live regions and 4 more are planned. So the Oracle AI database at AWS was GA'd July last year. So in less than a year, we released 16 regions. So as you can see, this is a very aggressive region rollout, which is happening across all the multi-cloud partners. Next one. All right, so I'm going to cover a couple of recent launches and features which we released across the multi-cloud partners and our services running in those partner data centers. So first one is the cross-region data guard with customer-managed TDE keys. So we've always had cross-region data guard support for Oracle-managed TDE keys. And now for customer-managed TDE keys, which are stored in cloud-specific key management services such as Azure Key Vault for Azure, AWS Key Management Service, or Cloud Key Management Service for Google Cloud. So if you have your TDE encryption keys, which are customer-managed keys stored in the CSP-specific services, and if you want to do cross-region data guard, you can do that for Exadata database service on dedicated infrastructure with this announcement. Some of the things which would be required as part of supporting the cross-region data guard is the encryption key resource needs to be replicated from the source region to the destination region wherever you want to have the another standby or the cross-region standby running for your primary. And that may include replicating the vault or the key ring or the encryption key itself. All right, next one. Okay, another recent launches is the high performance networking for Oracle AI Database at AWS. If you are familiar with AWS EC2 placement groups, it's the extension of EC2 placement groups, which is done for Oracle AI Database at AWS. What that means is when you create a ODB network, a placement group is created along with the ODB network, and you can use that placement group while creating your EC2 instance. So what it does is it maintains the close proximity with the Oracle AI database at AWS. So the applications, if they're running on your EC2 instances, they're placed in proximity with your Oracle AI database at AWS, which ensures you get the consistent sub-millisecond network latency from your applications to the databases running in Oracle AI Database at AWS. Now, this is on top of what we have currently, which is the Exadata infrastructure, where these services are running are natively placed in AWS data centers. So this is further optimization of that network latency. What you can do is you can create the placement groups and have your EC2 instances be part of the same placement group. There is no additional cost for using these placement groups, and you can also share these placement groups across AWS accounts if they are part of the same AWS organization. And that can be done using AWS Resource Access Manager. All right, next one. All right, so the next one is autonomous AI database on dedicated infrastructure in Oracle AI Database at Azure. I'm glad that we have an expert to talk more about this. So over to you, Robert.
All right, thanks, Vishal. Okay, let me share my screen. Okay, you guys can see this.
Yes.
Okay, so yeah, so excited to be here and talk with you folks about this launch of autonomous AI database now at Azure and multi-cloud. So now it's been available in AWS for a while, and we're now making it available in Azure. Um, Nathan actually kind of introduced autonomous database to some extent. It's what from a cloud perspective, fully managed, cloud native, the best experience that we would expect you could get from Oracle databases in our cloud service portfolio. And a little bit more specifically, what it is it's a platform for data management. It's not just the database. I mean, it is the Oracle database running on Exadata, and basically created and automated through AI using all of Oracle's best practices. And there's an AI-driven operational layer that's managing its health, and it's also sort of oriented towards different workloads. So out of the box, JSON-oriented workloads or just mission critical sort of transaction processing versus Lakehouse. And there's a whole bunch of features that are built into those things. So depending on what kind of workload, you're dealing with, you may end up, using the Lakehouse, and then you have access to, data catalogs and Iceberg, data formats and tokenization and vectors and LLMs and all that stuff is kind of, built into it. Okay, so it's more than just the database itself, and all these other components are managed as part of the platform. So you get a managed database, but you also get a bunch of other managed capabilities that support what it is that you're trying to build and deliver. Okay. And the whole idea behind this is that operational layer, that AI-driven layer where we're basically monitoring just thousands of metrics and alarms set on those metrics in the back end, and then automation as well as people when the automation isn't like 100% able to cover and respond to something fully automatically. There's Oracle experts there, but the whole idea is that we really drive down the customer-oriented interactions with the support organization and all that in this model. Most issues are detected by the service operational layers and responded to through ops and all that. So it's not the customer having to go and file SRs to get somebody to come and look at an issue. We're proactively looking at issues. And in fact, you can even register so that you understand that when we're proactively looking at issues, you know that we're looking at those issues, right? So, and when it's, again, nothing is ever perfect and everything is always changing. So when there are those times that you as a customer do go and file an SR because of something you're seeing, the time to resolution is much quicker because we have full access. There's no back and forth. Our support organization can click an API and do a log dump and all this, and they can immediately start looking at everything. So even when it's that small gap where a customer initiates something, we respond much quicker. So it just provides a better database experience overall. It's a fully managed experience. Okay. Now, for the autonomous database, we kind of have two deployment models where, yeah, it's fully automated. We manage everything, but you have a choice of deploying that in a serverless model where, it's very, very simple. You don't think at all about any of the infrastructure layers, and you just specify how much compute and storage you want, where you want it, and it's off and running. Okay. And that's been there in Azure for a while. And so what we've just launched actually is a dedicated version. Okay. And dedicated, gives you your own full infrastructure stack that's only you. It's one customer, right? So it's not that classic multi-tenanted kind of cloud-based service. It's a stack just for you. And that allows us to give you more control to isolate for production and mission critical workloads, control software versioning and things like that in ways specific to certain applications, and basically just to add a little bit more governance and trust and verify oversight. And then it just so happens that because that's a dedicated version, it's also the same version that runs in our what we call cloud at customer. So for customers in really highly regulated industries, sometimes they want the advantages of these cloud services, but they want them in their own data center. So this dedicated version is the same version we're going to talk about now that's running in Azure and Oracle Cloud and AWS. Well, you can also get it in your own data center. Okay. And so the whole idea behind the dedicated infrastructure is that it still needs to be elastic, as in, it's still a cloud. So you still want to be able to fire APIs and, and even manage the infrastructure and its growth over time. And so this autonomous database dedicated, like the Exadata database service, is on that flexible infrastructure layer. So you can start out with like a minimum number of physical servers, right, that fit what you need today. And then as your needs grow, you just fire APIs in an online manner. That infrastructure grows, right? Whether it's at the compute layer or it's the storage layer, you can just keep growing it over time as your databases get larger, as you add more databases, the infrastructure just, can keep growing based upon your needs, right? So that allows you to manage the cost of this dedicated infrastructure over time. Okay.
Hey, Robert,
And
sorry to
yes.
interrupt. There's a little reminder pop-up that's obscuring part of the screen.
Oh, sorry.
Awesome. Thank you.
I thought I closed that. Okay, so yeah, so the whole idea behind these dedicated servers is, there are some sort of strict regulatory corporate requirements, for isolating production databases and all that, and clearly the dedicated servers satisfy that stuff. But it's more. It's more than just these dedicated servers. It's because it's dedicated to one customer, we can add this customizable lifecycle policies. And so you can control the level of isolation that any given database has. You can control the software versioning. You can control the maintenance. You can control, your very, very stringent RTO, RPO requirements. And then importantly, you can also run all of this co-resident with Exadata database services. So you may have that flexible infrastructure already there. You may have VMs that are running Exadata database services, and then you want to modernize and take advantage of the fully managed nature of autonomous. And so you literally can, you can move or you can run adjacent these autonomous based services. Okay. Let me go. Okay. So this is what you end up with. You end up with not just the autonomous database, which is that thing on the right, but you also end up with the infrastructure resources. So you can create one Exadata infrastructure and grow it out over time, one system, okay? Or you can create separate systems for very, very important databases where you want that database to run on their own infrastructure, okay? And then within these systems, you can deploy uh, various VM clusters to isolate different application teams or different databases into their own environment, and then they get their own network isolation, and they get their own control of memory cores and storage and all that stuff for their VM. And then within each of those VMs, you can also run Oracle's multi-tenant, and so you can run multiple containers that are different database versions, managing backups relative to the needs of that particular database, controlling your encryption keys at that level, delivering your SLAs, your replication, and all that stuff through the container. Okay, and then you get the autonomous database itself, which is exactly the same thing you get on the serverless experience. It's the same API, right? But so you can control your infrastructure stack, and then you basically get the same thing as a serverless. Okay. And so having all that isolation capabilities and the ability to control the software versioning and all that allows you to provide functional isolation guarantees and change management. So this allows you to cleanly separate, for example, your development environments, from your UAT, from your production, and you can control that like any kind of change management that happens always goes in through your development. All the software updates happen in development and we're, first, and then eventually you can roll those things out into your UAT environments and you can have extensive testing cycles and all that to make sure you're happy with it. And then eventually it goes out to your production. But you can do all that through policies. So you set up policies that defines your governance model, and then all the autonomous AI operations just honors your policies. So it's not like you have to go and touch every single database, all the time in order to make sure that things are staging. You set up the policies, and then the software automation drives the process in a hands-free manner going forward. Okay. A little bit different from the serverless model where you're just always on the same software version patched at the tip. Okay. So you can control how you transition from one quarter to the next over time to be absolutely sure for like really super critical production databases that you vet everything before it rolls out. Okay. And one of the other differences, not just from serverless or from Exadata database service, um, in the Exadata database service, when you assign a bunch of resources to a VM, we bill you for all the resources immediately and continuously. Whatever's allocated to your VMs, we're billing you. And that's because, as Nathan was describing, you have administrative access. You can log into those VMs. You could do anything you want in those VMs. You could install WebLogic servers if you're or Kubernetes clusters, right? We don't really know exactly what you're going to do. So when you allocate the cores, we begin to bill you. Whereas on the autonomous database side, it is a data management platform. It is a database. And there's nothing you can do except issue our API calls. Okay. And so because of that, we let you stand up these VMs and we don't bill you when you stand up the VMs. So therefore you can have like a really big development playground VM, right? And you can have UAT VMs and eventually prod VMs, and you're not being charged. You can put all that stuff in place. Okay. And then you can create even your containers inside those. And again, no billing for those containers. It's only when you actually create an ADB, an autonomous database, just like in serverless, and you put it inside a container and it's actively running that we bill you, right? So it's a very different cost model. And what this also does is it allows you to set up a governance model with virtually zero cost. And then as you create databases, they basically drive through that cycle. And it's hard to do that in the other services because if you set up a great big development, VM playground, we're going to bill you for all the cores on that big VM, right? So it's more expensive to set up, a full-on operational life cycle at a reasonable cost point. And then there's all these other features in autonomous database as well that help lower your costs, like auto scaling of the database itself in our elastic pool model, which I'm not going to go into in great detail. And then there's also developer instances that you can run for free, right? So just a little, these are the differences between autonomous database dedicated and what you find in the Exadata database services. And these are things I'm going to walk through in the console experience so you can get a better feel for it in the service. And the last thing that I wanted to talk about was we have this enterprise security control capability that we call operator access control. And for these very, very important and regulated environments, oftentimes, the customer wants to guarantee that no human can ever get at the database. Okay. And in fact, anywhere in the infrastructure stack, not the infrastructure layers, the virtualization layers, the containers, databases, et cetera. Right. And so we built this custom service working with lots of very, very large banks and telecoms to where you can register in these physical environments with this service. And then it basically takes all of the infrastructure in our Bastion, jump servers that allow our operators to get to physical hosts, and it externalizes those so that our operators can no longer even get to anywhere in the stack. And so then you as a customer control the entry to the stack. So if it's ever a case in autonomous database where our AI automation layers are not just automatically responding and operating and doing the things they need to do, if there's ever a gap in that and a human has to do something, it has to go out through this service and get approved by the customer. And then the customer can watch the keystrokes and they can be pumping all the logs out to their own SIEM systems and all that so that they're basically having oversight to that human involvement. Okay. And this is available in Azure. So if you're running autonomous database at Azure or at AWS or OCI, you can register the autonomous VMs with this service and control that, potentially human access requirement. Okay. So now I'll do a walkthrough, and for that I'm gonna jump out to uh, the browser, and I want to some of these points that I was touching on. I want to show you how they manifest in the service itself. Okay, so if you go to the Azure portal, if you don't see the Oracle AI database at Azure, just search Oracle up here and you'll find it, right? But you would go into this service. And okay, and then you see the services we have available, which Vishal reviewed. And if you were to scroll down, you'll see that you have now the autonomous database on dedicated infrastructure. Okay, so you've got the regular serverless stuff, and now you've got the dedicated stuff. Okay, and if you were to look here, this is one of the things I want to make sure it's clear. If you look at this autonomous database on, sorry, I have a garbage truck coming up. If you look at this link here and you click on it, you're really going to the serverless stuff. Okay. The dedicated, uh, the dedicated autonomous database at Azure is implemented by something we call the flexible integration model. Okay. And this is actually coming to all of the services. It's not there yet. It's only there for the autonomous database dedicated. But what this flexible integration does is it allows you to provision the entire stack from infrastructure to database using either the cloud native specific APIs or the OCI level APIs. Okay, so you don't have to jump back and forth between these two in order to ultimately use all of your resources, which is the experience today. Now, you'll be able to execute everything on both sides eventually. Okay, and so dedicated has that flexible model. And so really, to get at the dedicated side right now in this first phase, you go into the Exadata database services, okay? And you look at infrastructures, okay? So, because remember, you can run both autonomous and non-autonomous on the same infrastructure, okay? So here, if we come to the Exadata database services and find an infrastructure, well, this is an infrastructure where you can run autonomous. So you click on that infrastructure and go into it, and this is the same experience as you have with Exadata database service. You can see the details of a particular infrastructure, and you can create more infrastructures, here natively in the console. Okay. In this case, we've got one, and so I'm going to show you. If you go to OCI, just click on this link, go to OCI, you now jump into the OCI side of the services where you're looking at that same resource. Oh, and it's going to make me log in. Okay, we are secure. Okay. All right. And so now we're looking at that same infrastructure resource on the OCI side. Okay. And again, this is a flexible infrastructure. So, you can see the details of it. You can see how many database servers are assigned to it and storage servers and what the total resources are that's available to it, et cetera. And then importantly, you can see the maintenance scheduling and you can control that, right? So this again goes to governance. You can set up a policy about how and when you want that maintenance to be applied to the infrastructure. And then you can scale that infrastructure. Okay. And so you can add compute servers, right? Up to 32 compute servers, right? You can add storage servers, right? Up to 64 storage servers, and again scale that infrastructure over time in a flexible manner. Okay. Um, and when you and when you do that, you just get more physical resources to use. Okay. And you'll use those physical resources by assigning them to VM clusters. Okay. And so here's, the list of Exadata database VM clusters on that infrastructure. And if you look at database servers, these are, you would see a growing list of servers if you were to add more and grow it. But if you click into one of these, just as an FYI, you can see the virtual machines that are assigned to your Exadata database services. Okay. And you can also see your autonomous virtual machines. So in this case, on this infrastructure, there's actually one autonomous VM that's running. Okay. And you can see that through these infrastructure details. All right. So once you have an infrastructure and you want to create autonomous, what you do is you come over to the Oracle AI Database Services. You go to Autonomous AI Database on dedicated infrastructure. Okay. And when you go to that and look at the resources available to you, now you see all those resources that I was describing in that slide, right? You see that you've got the Exadata infrastructure itself, right? Which is the same infrastructure that we were just looking at and we navigated to the OCI side from. Okay. We can also scale that here, right? If we drill into this, right, you can scale it on either side. And then you've also got the autonomous VM clusters and the autonomous container databases and the autonomous databases, right? So if we drill into this infrastructure, okay, you see that you have, again, the same thing, full details, the ability to change your maintenance scheduling and all that stuff that we just talked about. And then you see that you've got autonomous Exadata VM clusters. Okay. So if you click into that, you can see the VM clusters associated with this infrastructure. Now, every resource is created relative to a compartment, into a resource group on the Azure side. And so, here, if I change compartments to where I know that I've got that VM, right, then I will see. Oh, I guess that's not it. Then I will see the VM. Okay, so this is the VM that's inside that infrastructure. Okay, and I can create more of these autonomous Exadata VMs right here just by launching this. Okay, running through the dialog and allows me to create, another VM. Okay, which includes attaching the network that you want to give it a specific network, includes all the maintenance setup, whether or not you've got a custom maintenance schedule. So now you can see where you can align the infrastructure maintenance with the cluster maintenance, right? And get those flowing so that all the dev stuff gets done before the UAT, before the prod, etc. Okay, and just set it up as preferences. Um, and so yeah, and so you can also scale the VM. Okay, same thing. You can scale the oh, in this case, sorry, I'm at the infrastructure layer. If I click into the VM, okay, I can see the VM details. Okay, and uh, and then I can also go in and scale the VM cluster. And when you scale the VM cluster, right? You can scale your compute count, your how much storage, how many eCPUs, and it gives you a summary. But the net of it is, however many cores and storage and all that stuff is available in your underlying infrastructure, it's going to be made available to you to scale your VMs. Okay, so if you start to run out of storage, you can add storage servers, and then that'll increase your total storage. And then you come here and you can basically add more storage to your VMs. Okay. Um, and so, it gives you also then ability to view maintenance, what's if there were any maintenance events scheduled, right? Or you can look at the history and see other maintenance that's already occurred. And you can look at your virtual machines, across each of those hosts, etc. But importantly, you can drill in further and you can look at the container databases. Now, same thing. This needs to be in the right compartment to find the container databases. So here's a container database that's inside that VM. Okay. And so you can go in and get to the container databases and look at all of its details. Okay. Including, importantly, its maintenance schedule. Okay. And if you want, you can go and edit your maintenance preferences. So for every container, you can decide, again, similar to the infrastructure in the VM, how you want the maintenance to happen, whether or not you want to take the very latest, quarterly patches, or you want it to lag. You can set up custom schedules so that you can set exactly when you want that container to patch, etc. Okay, and that allows you, the combination of this control across infrastructure, VM, and container allows you to set up governance. Okay, and then the automation will just follow your preferences to roll everything out. Okay, um, and the container database also has other controls so that when you provision one of these container databases, there's some stuff that's like very specific because it's dedicated, things that you can do to control, for example, the underlying real application clusters. So you can control, like in large clusters, whether your databases are going to open and grow vertically on one node, and rather than leveraging the rack cluster except for failures, right? Or you can control the split so that your database is open on multiple nodes, in order to give you a little bit more availability during failure events, right? Not just failure protection. Those kinds of things can be controlled in autonomous database on dedicated infrastructure. Okay. And similarly, you can drill into any one of those containers and you can get to the underlying autonomous databases. So let me go again to the right compartment, and you see the autonomous databases. Okay. And for all of these, you can provision, directly from one of these list pages, right? You can always create another autonomous database. And again, this is where when you're creating an autonomous database is where you declare, hey, I actually want a lake house. I'm going to use catalogs. I'm going to do data sharing. I'm going to do all, iceberg, Parquet, all that stuff, right? Or you can say, I'm going to do a transaction processing system, and that changes the whole underlying best practices in terms of how it is that we create that database and whether or not we're using, caching, versus indexing and all those kinds of things. We automatically set up the best practices. All you do when you create an autonomous database in dedicated that's different from serverless is you have to pick which container database you want it to go to. So in this case, if you go to the right compartment and you can find an autonomous database to go to. Okay. And so one of the things that I wanted to show is you also have this ability to create developer databases. Now, if you create a developer database, it's free. So you can create the VMs for free, you can create the containers for free, and you can actually create databases for free, right? So and it's unlimited. You can create an unlimited number of these developer databases for free. And yes, they're limited, they're constrained in terms of how much resources, how much storage, all of that. But nonetheless, you can literally set up and play with autonomous database dedicated if you're an existing Exadata database service customer for free, right? Play around with it. Okay. Yeah, and you set your storage, give admin credentials, etc. And you're off and running. And I don't want to go into all the details, but it's that simple. And for the autonomous database, you have all the same capabilities that you have, um, in serverless, right? Except we also have some additional flexibility in terms of encryption key management and rotation and all that stuff. But you can edit your maintenance preferences from here. You can schedule maintenance from here. You can deal with your backup retention and your cloning and all those same things. Okay. And then also importantly, you have autonomous data guard capabilities. You can add standbys for your autonomous databases, right? Right here from the console. And those standbys can be local, right? So in another AZ in Azure, right? Or they can be cross-region, and you can have both, right? So it's really very, very simple to add a standby to your autonomous database and dedicated infrastructure, and then you can control, whether or not you want your maximum performance capabilities or whether you want, maximum availability, uh, etc. Those controls that you get with Active Data Guard. Okay. And in autonomous dedicated, if you're familiar with serverless, you might know that you can't read from the standby side in serverless. You have to create a clone and basically read off of clones. But on the autonomous dedicated side, we allow you to read off of your standbys. Okay, so if you create a standby database from your primary, you can do all your reporting and all that stuff off of your standby database. Okay, so it's again something a little different. All right. And that's it. I mean, that's kind of the main walkthrough. The only other thing that I wanted to show you is again that for these really important databases and regulated customers, um, we have this operator access control service. So the operator access control service, um, you can have your VMs registered basically. So you can create an operator control and you navigate through and you find, whether or not you're going to register an Exadata infrastructure or an autonomous VM or a compute instance, etc. Okay. And one of the things you'll notice is when you're doing Exadata infrastructures, or you cannot do it in public cloud. You can only do it in cloud at customer. Okay, but for VMs, for autonomous VMs, you can do it in cloud at customer, but you can also do it in public cloud, right? And this is where it comes into play for Azure. Okay. So you can register your VMs with this service, and there's a whole bunch of controls on operator access that, I would need an entire another session to go through it. But very sophisticated controls for you to, pre-authorize certain types of access or what have you, or, add full control and register your SIEM systems and all those things that you would do. But it's very easy, right? You just, click on this operator access control and register your VMs and set things up. Okay. And so, yeah, so that's uh, really the walkthrough that I wanted to provide you today. So I'm going to go back to the slide presentation and we'll go forward from there. And because I think we're going to take questions here at the end. So yeah, so hopefully you found that interesting. And then the other thing that I wanted to share with you is many of the things that I just talked about here, you can find in-depth detail on through these additional resource links. There's a blog on the general, what's dedicated for Azure all about, right? There's a blog on like, what highlighting what are those differences between Exadata database service and autonomous and how they work together, right? There's blogs on all the cost saving features of autonomous, the auto scaling and elastic pools and all that stuff. Something that shows you how easy it is to migrate, right? And something that walks you through the operator access control. So there's deep dive blog links here. And then, basic documentation and data sheets and all that stuff, API references. Okay. So I would encourage you to check this stuff out. And that will really put you in a great position to try this stuff out. Because again, it's free. Like especially if you're an existing Exadata database service in Azure, you've already got an infrastructure. You can set up the VM, the container, and a database for free. right? So it's very easy to check this stuff out. And with that, I'm going to turn it back over, and then we'll go through, I think, some question and answer and some closeouts for the session.
All right. Thank you, Robert. That was awesome. Okay. Just wanted to remind everybody that we do record all of these sessions and we do post all of the recordings on YouTube on our channel, which is the Oracle Database Product Management channel. So the recording for this session will be up there either later today or tomorrow. So feel free to peruse all of our previous sessions. There's close to 40 now. So if you've got a question about a particular topic, chances are we've covered it in some form or another in the past. And if you have requests for topics, please raise those during this session. We got one today to talk about the interconnect. And it's been a while since we talked about the Oracle Interconnect with the other cloud service providers. So we'll be glad to add that to our backlog for future sessions. So all of that said, I'm looking, I know we had a couple of questions that Vishal, you answered. Any other questions that I'm not seeing?
There's one question just now. I see it. It's about the AWS and Oracle interconnect. Question from Rachid. Mostly the reliability and the latency between AWS and Oracle. And I think we should, as Nathan mentioned, we will have a follow-up session on that one in one of the future multi-cloud happenings, so that we can come up with, all the interconnect solutions we have for all the CSPs, and we can give you those details.
Thanks, Vishal. Any questions for Robert or around autonomous AI database? Be glad to take those now.
Okay, hopefully that means that I did a thorough job.
I think, yeah, you answered everybody's questions proactively. Well, it was a really great presentation. So thank you for that, Robert. And thank you all for attending. We really appreciate it. And we'll look forward to seeing you on a future session. So I'm going to stop recording.